Now we want to step through this program and open it using GDB to see how these codes have been translated to the assembly code. So I press Ctrl Shift and T and say GDB the array program in here and break at main and run. Also, if you pay attention, when we compile this program, we didn't add or export any symbols to the program. That's what usually the software developers do. They wouldn't add, or they would strip away all the symbols so that it would be hard to get reverse engineered. They don't want their software to get reversed and people reverse engineer it and understand how it has been created, so they wouldn't add any debugging information. That's what we have done. We didn't add any symbols because we want it to be hard, and only by looking at the assembly code we want to understand how it does what it does. So you see, if I say list in here, we wouldn't see any code in here, and it says no symbol load table is loaded. Okay, now we say set disassembly flavor to Intel, and we say disassemble the main part. These are all the codes. If I hit enter, you could see the other pages. It has been translated to all of this code. So again, right now the three instructions, you know what they do. The first instruction stores the RBP value in the stack, then moves the RSP inside the RBP, then subtract the RSP by 0x20, which if we enter our calculator in here, the Python interpreter, and type 20, and we see that it's equivalent to 32. So what this means is that the length of the stack has been increased by 32 bytes. After that, the first instruction says move 0x18. 0x18 is equivalent to 24 in decimal. 0x18. So move this value inside the RBP minus 8 and use 4 bytes for representation of this number. So you see it's equivalent to the first instruction in here. We said that the variables, the integer, this integer variable is nothing but a placeholder. So an address has been assigned to this a variable to hold the number of 0x18, and using the div word in here, it says that use 4 bytes to represent this integer, which we talked about how GCC does that. After that, we have 3 instructions in here, which all of them say that move 0 to these addresses in here. What we are going to do, actually these are for garbage removing, because we know in every memory address there might be some garbage value. These instructions would move 0 to these memory addresses. What we are going to do is to open another terminal and create a file to just create a layout of the memory related to this process. So first of all, I want to say a step I, so that the length of the stack has been improved or increased. Then I say info registers RBP. So you see, this is the RBP which would be in here. So this is the address of RBP, and then we say info registers RSP, which is this one. Now before that, if you look at this instruction which says subtract the RSP with 20, and we explained about that, if I say int and paste the value of RBP, this one E1B0, which was the last RSP, and convert it to the decimal in here, and say minus 32 and convert it to hexadecimal. We explained about all of these things. We get to this value, which would be the new RSP. Now if you look, it says in here, when we said info registers RSP, it says the same thing. The difference between the current RSP and the last RSP, which is saved in the RBP, is equal to 32 bytes. Therefore the RSP would be in here, the address of the RSP would be in here, and the difference between these two addresses would be equal to 32. Now the first instruction in here says move the, as we said, 0x18 using 4 bytes at RBP minus 8. What I want to do is to first specify these addresses, RBP minus 8, RBP minus 20, and RBP minus 18. So in here I say RBP minus 8 would be equal to this address. I want to copy this, go here, and paste this here. So this would be RBP minus 8, right? Or just 8 in here in decimal. So the difference between these two would be 8 bytes. Then we have RBP minus 20. First, let's see. Yes, 20 is equivalent to 32, right? So the second one, yes, 20 would be 32. Therefore, this is the RBP minus 32, right? So this would be RBP minus 32 or RBP minus 0x20. All of the things are the same. After that, we get to RBP minus 18. RBP, first we should see they are 18 in the hex is equal to 24, right? So in here I say 24, and this would be RBP minus 24 or 0x18. Therefore we would have the address in here. So I paste it, and this would be RBP minus 24 bytes. As you see, the difference between these two is equal to 8 bytes, 32 to 24, and the difference between 24 and 8 would be 16 bytes, right? So the next one says RBP minus 10, because 10 in hexadecimal is equivalent to 16. So in here, if I say 16, we would have this address in here. So I copy this, go here, and this would be RBP minus 16. So again, we have RBP, RBP minus 8, RBP minus 16, RBP minus 24, and RBP minus 32. Now we want to see how the instructions work. First of all, it says move the 0x18 as a D word or 4 bytes into the RBP minus 8. Therefore, here to 4 bytes later would be, so we would have 0x18, then 0x00, then 0x00, and then 0x00, right? If I just look at this memory address, you could see that we would have 0x18. So in here, no, actually you go to the GDB, I paste this in here, use the X command for XB, and you see, well, we don't have anything because right now we haven't disassembled, we haven't stepped through the instruction, because this instruction should get executed. Therefore I say a step I, and then execute it again, and now we have 0x18, 0000, and 00. You could even write all the single addresses of all of these 32 bytes and understand which bytes is in which memory cell. But I think having a layout like this would help a lot in reversing a software, and you would see how it would help us through the rest of the program.